హలో.
అన్నయ్య
సంతు స్టార్ట్ చేసావా? కాదు, ముబీన్ ఇది ఎక్కడుంది చెప్పు.
విండోస్ పి అని కొడితే అయిపోతుంది.
అది కాదు, ఇది ఫైల్ టెంప్లెట్
డెస్క్టాప్ పైన ఉంది.
డెస్క్టాప్ మీద ఉందా?
డెస్క్టాప్ పైన ఉంటుంది.
ఓకే, డెస్క్టాప్లో ఎలా ఏమని ఉంది?
వైటీ క్లాస్ టెంప్లెట్ అని ఉంటుంది.
ఓకే, ఒక్క నిమిషం. డెస్క్టాప్లో ఇదేంది లేదు కదా, టెంప్లెట్స్లో ఉందా?
వైటీ క్లాస్ కాదు కదా, డెస్క్టాప్ క్లిక్ చేయగానే పైన కనిపిస్తుంది వైటీ క్లాస్ టెంప్లెట్ అని.
లేదు ముబీన్, ఒకసారి నీకు వీడియో కాల్ చేస్తాను చూడు.
ఇది డెస్క్టాప్, ఇది కాదు డెస్క్టాప్ పైన ఇంకొక డెస్క్టాప్.
ఇందులో కూడా అదే అయ్యే వస్తున్నాయి. డౌన్లోడ్స్లో పెట్టావా?
లేదు, నేనేం మార్చలేదు.
డౌన్లోడ్స్లో ఏమన్నా ఇది వాట్సాప్లో డౌన్లోడ్ చేశారు?
ఇది మీరు మానిటర్ కదా యూస్ చేస్తుంది, ఆండ్రాయిడ్ ఫైల్ యూస్ చేస్తున్నారు.
మానిటర్ ఇది డిజిటల్ స్క్రీన్.
ఆ టెంప్లెట్స్ అని క్లిక్ చేయండి. అసలు ఇది కానే కాదు, ఇది ఫైల్సే కాదు.
మరి ఇది డెస్క్టాప్, ఒకసారి డెస్క్టాప్ మీద చూడు. ఇందులో ఉందా? ఇదా వైటీ క్లాస్ టెంప్లెట్? మరి అది ఓపెన్ అవ్వట్లేదు ఏంది?
మీరు నోటేనా ఓపెన్ చేసింది?
నోటే. ఇప్పుడు నోట్లో ఇంపోర్టా?
న్యూ అని కొట్టండి. కాదు కాదు, న్యూ అని కొట్టండి.
ఫైల్ న్యూవా?
న్యూ.
షూరా?
న్యూ.
న్యూ. ఓకే,
మళ్ళీ క్లిక్ చేసి ఇప్పుడు ఇంపోర్ట్ అనండి.
ఇంపోర్ట్ ఫైల్.
అక్కడ పైన డౌన్లోడ్స్ అనుకుంటా, అదే డెస్క్టాప్ అక్కడ ఉంది చూడండి, వైటీ క్లాస్ టెంప్లెట్. అదే
ఓకే ఓకే.
హలో
సంతు, స్ట్రీమింగ్ స్టార్ట్ చేసావా?
స్టార్ట్ అయింది, కానీ ఎక్స్టెండెడ్ అర్థం అవ్వట్లేదు అన్న, చూస్తున్నాను.
సరే వదిలేసేవా, ఇది పెట్టేసే. రేపు ముబీన్ దగ్గర అడుగు ఒకసారి, లేకపోతే ఈ లోపల ముబీన్ అడిగి చేస్తా ఉండు. ఇది స్ట్రీమింగ్ స్టార్ట్ అయిందా యూట్యూబ్లో? నేను లైవా? ఓకే, 9కి స్టార్ట్ చేద్దాం. ఒకసారి లింక్ పంపించు నాకు. అంతలోకి ముబీన్తో మాట్లాడి సెట్ చేస్తాను. ఇదేంటి ఇలా వచ్చింది స్క్రీన్? ఓబిఎస్
అందుకే చూస్తున్నారు. యాక్చువల్గా ఓబిఎస్ ఏదో అయ్యింది.
సరే, డెస్క్టాప్ మీద పెట్టేసి తీసేస్తున్నా. డెస్క్టాప్ మీద కరెక్ట్గా వచ్చింది. ఇప్పుడు డెస్క్టాప్ మీదకి వచ్చేస్తా చూడు. డెస్క్టాప్ కరెక్ట్గా వచ్చింది కదా ఇప్పుడు? డెస్క్టాప్లో కరెక్ట్గా వచ్చింది కదా? లింక్ పంపించా. నీ ఫోన్ వాడుకోవచ్చా? నీకు నైట్ కావాలి? నీ ఫోన్ నాకు కావాలి అన్నాను. నైట్ నీకు పుట్టినప్పుడు కావాలి నాకు. ఇంకో ఫోన్ వైఫై కనెక్ట్ అవుతుందా? Hi, is my audio clear, guys? So those who haven't joined Telegram channel,
guys?
Okay. Those who have not joined Telegram channel, this is the QR code of the Telegram channel. Please join. Okay. This is the QR code of Telegram channel. Everyone, please join. Right. Okay. So let's start some more questions. We will see 2 or 3 simple questions and then we will go to the next model. Okay. Okay. Fine. See, coming to TOC or any subject in general in if you look at the past 5 years question papers, okay, you can meanwhile scan this. So if you look at the past 5 years question papers, any subject, the questions are not repeating. See, earlier when I prepared for GATE, when I have taken the last 5 years question papers and solved them, the same questions, almost the similar questions used to repeat in GATE, and it was very easy when I have taken GATE exam. But now, since the competition has increased so much, because this year 2.5 lakh people have written GATE computer science and 85,000 have written GATE DA. Now that the competition has increased, they have increased the level of the GATE paper and they are not repeating the questions. Okay, for the past 5 years, if you observe the question papers of GATE, they are not repeating the questions again and again, but they are coming up with the new questions. But one good thing about what is happening in the last 5 years is uh, the questions are mainly from standard textbooks exercise questions. Okay, so this entire TOC course I have prepared from 6 textbooks in total. Okay, so anyway, the content of all the 6 textbooks, the theory wise, the content is same, but there are a lot of exercise questions which are different in all these books. Okay, so I have collected all these questions. Their solutions are not available anywhere on the internet, so I solved them, and with lot of effort I have solved almost all the models. And there are a lot of models in TOC that you can expect questions from, right? So we are going to solve a lot of models. Okay, see, the thing is, if I don't show you all the models, in exam you may not get an idea of how to solve that particular model. Okay, so we will solve all the models that are possible, so that uh, most of the questions will come from our classes. Okay, so if I miss out any model, the thing is, you will lose a rank and I will lose a rank. Okay, so we both should not lose any rank. So in TOC, we are going to solve all the different models possible. Okay, fine. So before beginning, I will just show you where to find the practice questions, where to find the notes, where to find the class notes and all. Okay, so good evening everyone. So let me just show you where to find class notes. ఇది ఎనీ టెస్ట్ తీసుకో సంతు కనిపిస్తుందా స్క్రీన్ లో so I'm going to show you I'm going to log in my website and I'm going to show you how you can find the lectures, you can find the class notes, the notes that I write on the board, and the handwritten notes as well as the printed notes. Okay, now the advantage of printed notes is it will be very small and it will be easy for you to quickly go through it. Okay, maximize చేసాంతు. Okay, you can type ravindrababuravula.in. Okay, so internet shows me as internet personality. Okay, then you can go to my purchases. There you will see what are all the purchases you made. then you can log in using your mobile number, or you can also log in using password. Okay, and once you log in, you can see the course. So let us say you are taken the course GATE 2027. అందులో అసలు వేరేది వైఫై కనెక్ట్ చేసి నాకు జస్ట్ యూట్యూబ్ చూసుకోవడానికి కాదు, ఇది వేరేదా? వైఫై కనెక్ట్ చేస్తావా? Okay, so now here you can see live classes. Two classes have been completed. And now you can go to TOC. There you can see 3 PDFs. Okay, so one PDF is about the class notes. So this is the handwritten notes. Okay, so you can take the handwritten notes. It is beautifully written. You can use this handwritten notes, or if you don't like to use handwritten notes and you have my this is the explanation that I have given on the digital board. You can see that explanation that I have given on digital board, but handwritten notes will be more beautiful. Okay, password. Okay, so this is the class notes that is available there. Now I will show you even one more notes, that is study material. If you click on study material, this entire class notes is printed in the textbook format. Okay, so this is all the textbook format of the problems and theory that I have discussed in the class, right? So you can use any one of them that you want. Okay, fine. Now let us see where to find the YouTube on just ఉంటుంది. Now let us see where you can find the practice questions. Okay, Santosh, ఇదే పైన ఇది బ్రౌజర్ క్లోజ్ చేసేయమంటావా? TOC 1 minute.
రైట్ సైడ్ లో ఒకటి ఎక్స్ మార్క్ ఉంది కదా, అది క్లోజ్ అయిపోతుంది. నాకు అవ్వట్లేదు క్లోజ్.
ఎక్కడ సంతు?
రైట్ సైడ్ టాప్ కార్నర్
ఇదా?
బ్లాక్ కలర్. యా ఫైన్. స్క్రోల్ డౌన్.
Okay. So here you are going to see the practice questions. Okay, so if you open it, you are going to see practice questions, right? So you can see finite automata and regular languages questions. Lot of questions are there, and along with that we are also going to upload even more questions. Okay, already lot of questions are there, you can practice them, and along with that we are going to upload even more questions. Okay, fine. So that is all about where you can find notes, where you can find practice questions, and where you can find the lectures. Okay, all the lectures are there and the notes is there, and also recorded lectures are also there. Next week I will tell you how to watch the recorded lectures, but try to watch the live lectures. Okay, try to watch the live lectures and open the Telegram channel and we will start. Open the Telegram channel please everyone, and I'll give you questions and we'll start. Okay, so join this Telegram channel guys, please join this Telegram channel. Okay, fine. Let's start now. Class notes and all. Okay. So, good evening, everyone. So, let me just show you where to find class notes. It is funny, volume is not increasing. Volume is not decreasing. Yeah. Okay. Udaya. Okay. Let's solve the problems now. So we'll start with simple questions and then we will complicate it. Okay. So let us say sigma equal to a comma b, sigma equal to a comma b, and language equal to set of all strings w such that w contains even number of a's. Why am I doing this? Because there is a linked question which is asked in GATE. We have solved this model where string length is even. Now I am asking number of a's are even. Okay. Now I am asking number of a's are even. Write the answer in the Telegram channel, guys. I'm seeing your answers. Number of a's are even. Oh, showing photos not allowed. Okay. Not able to send photos, huh? Okay, okay. Let me do one thing. Let me change the settings. Something has happened. I think group settings, invite links, permissions. Okay, send media. Try it now. Yeah, now we are able to send the photos, right? Yeah, please don't spam. You will be blocked. Okay, guys, someone is spamming. Can you please block? Let me see the answers. Yes. So almost all of you are able to do this, right? So we have seen this model. Yeah, everyone is able to do this. Only thing that you have to do is the regular expression. Okay. Very good. Most of you are able to give the regular expression as well. Okay. Most of you are able to do regular expression as well. Cool. But some of the regular expressions I am getting is this one, the most frequent. Okay. So even number of A's, right? So what do I mean by even number of A's? A's can be 0 or A's can be even, right? So 0 is also allowed. What do I mean by 0 A's? It is simply B star, right? It is simply B star. Or you are going to have 2 A's as the building block, and there can be any number of B's between them, and you can repeat it so that you get all the even number of A's, 0 A's or any number of even number of A's. Actually, this is a very basic regular expression. Okay. Actually, whatever I have shown you is a very basic regular expression. Later, I will show you even beautiful regular expression. Okay. Now I don't want to confuse you with regular expression, so let it be there. Later I will show you very beautiful regular expression. And what I have seen is some students are yeah, Rupam, your regular expression is right. Okay, I will come to the other regular expressions once we see the regular expression topics. Okay, so what I have seen is someone is writing like this: B star, A star, B star. Now because of this, all the A's will be together. You cannot put any B's in between. So this is wrong. If I want to generate ABA, this cannot be generated by this regular expression, right? And anyway, DFA and FA you already know. Okay. So 0 number of A's, you accept it. One A means it is a odd number of A's. 2 A's means even number of A's. Odd A's, even A's. Odd A's, even A's. Now we are not counting B's. Therefore, whenever a B comes, don't move, don't count. Only count the A's. Only count the A's. If this question has been about the string length, you should count A comma B together, because string length means both A and B. But here only A's. So that is why you are getting like this, even number of A's. Even number of A's. So this is the minimal NFA as well as minimal DFA. Okay. Everyone has answered it right. Very good. Everyone has answered it right. Very good. Okay. Yeah. What? Okay. Now what is the next question, guys? Can someone tell me what is the next question? Can someone tell me what is the next question? So always, whatever subject I am teaching, watch the live lectures, because the number of examples and the number of models I keep adding every year, right? So even if you watch the last year's recorded classes, still you watch the live lectures. Okay. Yeah. Very good. The next question is odd number of A's, right? So sigma equal to A comma B, language equal to set of all strings W such that W contains odd number of A's. W contains odd number of A's. You can do it the same way, right? You can do it the same way. But interesting thing is, how are you going to write the regular expression? I will later tell you even beautiful regular expressions, but now with the basic knowledge you have, write the basic regular expression that you can write. Later when we practice regular expressions, you are going to do it easily, okay? Now I am interested in seeing the regular expression. I am interested in seeing the regular expressions. Anyway, you will do a DFA and NFA directly, right? Yeah, Hamza, please take the new course. Recorded, this course is going to be better than the last course. Yeah. Dheeraj, your regular expression is going to generate Divi. Divi, your regular expression is going to generate even number of A's also. See this? Divi has given this. B star A, B star whole plus, right? Now what I do is, in place of plus I will put 2, okay? Then what do I get? B star A, B star concatenated with B star A, B star. Now here I will put 0 in the place of star. Here I will put 0, here I will put 0, here I will put 0. Now what am I getting, guys? I am getting odd even number of A's, right? Therefore this is wrong, right? I want you to write the regular expressions, okay? Very good. Someone has written it very nicely, and they have given multiple regular expressions. Who is this? Sharim. Sharim, very good, Sharim. And Rupam. Nice answer. Okay, we will discuss about the short regular expression. Okay, cool. So you know even number of A's, right? So even number of A's means there can be 0 A's or there can be any number of 2 A's. You are going to use it multiple times. Therefore, this is the regular expression. Later I will show you how to write a better regular expression, but for now let's go with it, okay? Now you know that this is even number, right? You know that this is the even number of A's. Now what we have to do to make it odd number of A's? Add a, fine. Now this is even number of A's followed by a, therefore it is odd number of A's. But the problem is, this is always going to end with a. That is the problem, right? How are you going to fix it? See, this is odd number, this is even number of A's. You know that. Just now we done it. Now I made it odd number of A's by adding a. But if I put a here, whatever happens here doesn't matter. It is always going to end with a, which means we are getting all the odd number of A's that are ending with a, right? So, but then odd number of A's can end with a or end with b, right? So just to include that case, I will put b star. Cool. So this is the regular expression, but later we will see even better regular expressions, okay? For now, stick to the basics. Now, I can write one more regular expression as well. There are many regular expressions possible. I am just showing two of them now. Later we will see lot of them, okay? Now, this is the even number of A's. Now make it odd. I will put a here. Now what happens? This is even number of A's and this is a odd number of a. Fine. But the problem is, whatever happens here doesn't matter. It is always going to start with a. But odd number of A's can also start with b also, right? So just to compensate b's, I am going to put b star. So it can start with a b or any number of b's, and then it will contain a odd number of A's, right? Now, what is the minimal NFA and DFA? You know this. Everyone has done it, right? So odd number, even number, odd number, right? Even, odd, even, odd, even, odd, 0, 1, 2, 3, 4, 5, right? So you are not counting this. So let me put here. See, this is a very simple question. Why am I solving this simple question is, for the next question I need this, okay? That is asked in GATE, right? So This question, this is the minimal NFA as well as minimal DFA. This is both minimal NFA and minimal DFA, right? So can someone tell me, what would be the next question? So I will, before solving the next question, I will add one more question, okay? Just for fun, let's see this. It is also simple question. Sigma equal to A comma B, L equal to set of all strings W such that number of A's in W is congruent to 0 mod 3. Is congruent to 0 mod 3. You can easily do DFA and NFA for this, but give me the regular expression. Whatever you have learned from now, give me the regular expressions, okay? You can easily give DFA and NFA. We have seen this model. For the string length, we have seen this model. So you can give DFA and NFA very easily, but what I want is regular expression. Anyone, guys? Rupam, you don't have to type. You can write on the book and paste it. Yeah, Rupam is giving very good answers, but you will not be able to understand that answer now. Let's do basic answers for now. Anyone, guys? Anyone of you are able to answer this? Okay. So who is this guy? Divi. we are discussing only Divi's answers, right? We are discussing only Divi's answers. So Divi is right to some extent. Divi has given this B star A, B star A, B star A, B star whole star. This is okay, but what is the problem is, it cannot generate a B. Even B is in the language, it contains 0 number of A's, therefore B is in the language, but this cannot generate a B. How will you generate a B? See, if I put 0 here, it will become epsilon, so I have to put 1. Let us say I have put 1, then immediately all these 3 A's, 1A, 1A, 1A will come. You cannot generate a B. So how can you fix it? By adding 0 number of A's, B star. That is the regular expression. Very good. Who is this? Rudra. Very good, Rudra. Your answer is right. Okay. Later, I will show you even better regular expressions. For now, stick to the basics. Okay. Now it is very simple. Can you give me DFA and NFA? And almost everyone is able to give DFA and NFA. So let's not drag it too much. Everyone knows. So 0 A's, 1A, 2A, sorry, A here, right? 0 A's, 1A, 2A, and then again go back. 3 A's, 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. Now you are not counting B's, therefore stay at the same place. B, 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 right? Stay at the same place. This is very simple. We have already seen this, right? So this is the minimal NFA and minimal DFA. This is the minimal NFA and this is the minimal DFA. You have already seen this. right? Minimal NFA and minimal DFA. You have already seen this. Okay. Now, if the question is slightly twisted, now let us say the question is slightly twisted. Okay. So what twist can we add? What twist can we add? Can anyone say what is the twist can we add? So I will give a question like this. Sigma equal to A comma B, language equal to set of all strings W such that number of A's in W is congruent to 1 mod 3. Number of A's in W is congruent to 1 mod 3. This is also a simple question if you want to do DFA or NFA. But if you want to write the regular expression, you have to be careful, right? Using the basic knowledge you gained till now, write the regular expression. Later I will show you better regular expressions, okay? Yeah. I am not interested in DFA and NFA. Everyone will be able to do this. Very good, SDS. DFA and NFA, though, everyone will be able to do this. I am not interested in DFA and NFA. Right. See, what will be the DFA and NFA? 0 A's, 1 A, 2 A, 3 A's. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I am going to put B's here. B, B, B. Now I am going to put B's here. This is number of A's in W is congruent to 1 mod 3, right? Now what I want is, give me the regular expression for this. Give me the regular expression for this. Monica, you can generate even 3 number of A's. Monica has given this. See this? B star A plus B star A, B star A, B star A whole star, right? Now forget about this. Just look at this. I can generate 3 A's. How? I will put a 1 here, I will put a 0 here, I will put a 0 here, I will put a 0 here. It is going to generate A, which is 3 A's, congruent to 0 mod 3, divisible by 3. So this is wrong, right? Now use your, earlier also we have converted even number of A's into odd number of A's. Use the same method, right? Now let's take divisible by 3. And from the divisible by 3, we will see how to get congruent to 1 mod 3. That's it, right? So how do we get divisible by 3? The earlier expression was 0 A's or the building block is 3 A's, right? So B star A, B star A, B star A, B star. So whole star. This is congruent to 0 mod 3. Right? Now what do we want? We want 1 extra A. Okay. I will put 1 extra A. But what will this become? All these strings are ending with A. It can also end with B. So put a B star. Otherwise, one more expression is B star plus B star A, B star A, B star A, B star whole star. This is congruent to 0 mod 3. Now, I will put a extra 1A. Number of A's are congruent to 0 mod 3. I will put extra 1A. But the problem is this is always starting with A, right? So I will add a B star. Cool. Now even if they ask you congruent to 2 mod 3, you can do the same thing. You do the same expression which is 0 mod 3 ka expression. Okay. This entire expression is 0 mod 3. Now you have to add 2 A's. Okay. So if I add 2 A's, it is always ending with 2 A's, right? So add a B star here. Done. Or you take the 0 mod 3 expression, and then add 2A's, but it is always starting with 2A's. So add a B star, add a B star. That's it. Right? Right? Or you can take 0 mod 3, add 2A's. Add a here, add a here. But this is starting and ending with A. So put a B star here, put a B star here. So from one regular expression, you can convert it to other regular expressions, right? Okay, anyway, that is not my intention. This question somehow I wanted to solve, but the actual question I wanted to solve is different, okay? Actual question I wanted to solve is different. This is a very interesting question and it is asked in gate 3 times. So sigma equal to A comma B, language equal to set of all strings W such that number of A's in W is even and number of B's in W is odd. There are 3 different ways to do this. Number of A's in W is even and number of B's in W is odd. Or let us keep both of them even only. Let's not confuse you. Anyway, you can do any question. A's even, B's odd, B's A's odd, B's odd. You can take any combination, right? Can anyone solve this? And for this model of question, regular expression will not be asked. It will be very complex. The regular expression for this will be very complex. Give me NFA and DFA, that is sufficient. So this model comes under a model called grid machines, which I will solve. Okay. And for grid machines, regular expression is not asked. Okay. Answer me this question. Can someone give me the finite automata for this? And also tell me how you got that finite automata. What's wrong with this? So Shubham. Yeah, Shubham, your answer congruent to 1 mod 3, right? So you can generate 2A's. Is this what you are asking, Shubham? Shubham has given this answer. For this question, congruent to 1 mod 3, Shubham's doubt is what's wrong with this? B star, A, B star, A star, B, B star, right? So Shubham, I should have used a different color. So Shubham's question is, for this question congruent to 1 mod 3, for this question, he wants to give the regular expression B star, A, B star, A, whole star, B star. This is what he wants to give. What is the problem with this, guys? Can someone point out? I can generate 2A's, right? 2A's means congruent to 2 mod 3. In place of this star, I will put 1. In place of this star, I will put 0. One more thing is, all these stars can get independent numbers. It is not a rule that you have to put the same number in all the stars. That is not the rule. All these stars can get independent numbers also. Okay. So I will put a 0 here, right? And I will put a 0 here. Then what am I getting? A. That is why Shubham, your answer is wrong. Okay. But anyway, you will learn. Don't worry. Wow. Many people has given the answer. Cool, 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 cool. Many people have given the answer. Okay, okay. Fine, there are many ways to do this. Okay. So one way is you can do like this. First you construct even number of A's, right? Even number of A's, right? And then you construct even number of B's, right? B, right? B, even number of B's. So it is going to be A's and it is going to be A's. So this is even number of A's, this is even number of B's. Now let us say this is state A, state B, state C, state D, right? Then you can do a method which is lengthy method. So I will teach it, but don't use it in the exam unnecessarily, right? I will teach it, but don't use it in the exam. Okay. There is a method called cross product or Cartesian product, right? Now you have A, B, C, D, right? A comma B are the two states here and C comma D are the two states here, right? Now if you apply the cross product, you are going to get four states. Let's name one state as AC, right? And let's name one state as AD. Let's name one state as BC. Let's name one state as BD. Now you construct a DFA, right? Now you construct a DFA with all these states. This is called cross product, right? But it is going to be lengthy. I'll show you, but I'll still show you, but don't use it in the exam. I will show you other methods also, but you see which one you can do fast, okay? Some people might find it fast, so it is up to you. Now let us say AC is a state, right? And then AD is a state, and then BC is a state, and then BD is a state, right? Now what are the final states here? A and C. So whichever state contains A and C will be the final state. Okay. What is initial state here? A and C. Therefore that will be the initial state. AC is the initial state, right? Now just see where A is going on small a, it is going to B, and where C is going on small a, it is going to C. Therefore it is BC. Just see this, okay? AC, you are talking about AC transitions, right? AC, AC, okay? So capital A on small a, capital A on small a is going to be, and capital C on small a is going to C. Therefore, you have to put BC. You have to put BC. Right? Now, similarly, if you fill the entire thing, you can get it. Right? But I am directly doing it. You will get A, you will get B, you will get B, you will get A, you will get A, you will get B, you will get B. Okay. So this is a lengthy method. Taking two finite automatas and then applying the cross product and getting the answer is a lengthy method. Okay. Don't do this. And what is the other method we can follow? The other method that we can follow is, if you observe any string, there will be, see now what is that? A's have to be even, B's have to be even, right? Now if you take any string, there will be two cases, right? Right? Four cases. Take any string, number of A's and number of B's, there will be four cases. What are the four cases? Even number of A's, even number of B's, right? So for example, epsilon, right? Or AABB, right? Similarly, even number of A's, odd number of B's. What is the example? AAB, even number of A's, odd number of B's. Or even simply B is also an example for that, right? Now, odd number of A's, even number of B's. So simply A is an example, odd number of A's and B's, or you can also put A, B, B, odd number of A's and even number of B's, right? Or odd number of A's and odd number of B's. Simple, right? So odd number of A's and odd number of B's is, you can say AB. Odd number of A's and odd. Any string you take, you can classify it into 4 classes. Therefore, our finite automata will have 4 states, right? So even, even, and epsilon is there. So epsilon is even, even. So this has to be final state because we want even number of A's and even number of B's. Even this is also little bit lengthy, but you can do it, okay? So now even number of A's and even number of A's, if I get a, what happens? Even number of A's plus A is odd number of A's and even number of B's will be same. If I get one A, A's will become odd and B's will be even. Now if I get one more A, it is already odd number of A's. If I get one more A, it will become even number of A's and even number of B's, right? Right? Now let us say I get a B, then what happens? A's will be even, but B's will be odd. Now if I get one more B here, already B's are odd. If I get one more B, B's will be even, right? Right? This is a very important question asked in GATE 3 times, okay? Now, if you want, if you get a from here, then what happens, guys? A's will become odd and B's are already odd, therefore odd, odd. If I get a here, A will become even and B's will be odd, right? Now if I get a here, A's are already odd, so A is done, B. Now if I get a B here, B's are already odd, sorry, B's are already even, so B's will become odd and A's are already odd. Now odd B's, odd A's, odd B's. If I get a B, then A's will be odd only, but B's will become even. You can use this method. You can use this method, right? 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 Some people are doing it with 3 states. 3 states is not possible, no. 3 states is not possible, right? And don't give me regular expression. So now they can ask you any question. If they say A's are even, B's are odd, right? So A's are even, B's are odd. This will be the final state. You can answer any such question, right? Now I will show you an easy method. Okay. Now let us see RBR method. So this is the textbook method, which will take some time, and this is my method only, but it will also take some time. Now I will say the new method, RBR method. You will not find it anywhere, and we are going to solve a lot of questions using RBR method, and there will be lot of questions with RBR method. Okay, so we know that A's have to be counted, right? A's have to be counted even odd. B's have to be counted and both of them are even odd, right? Fine. Now let's count the A's horizontally. Let's count the A's horizontally, right? Let's count the A's. See, here there are 2 states, here there are 2 states. So we know that there will be 4 states. So let's count the A's horizontally and let's count the B's vertically. You can change it also, okay? You can change it also. I am counting A's horizontally, I am counting B's vertically, right? Now let's apply my method. You will be able to do it very fast, okay? What is my method? See this. I will draw a line like this, okay? Now in this line, b's can be anything. B's can be 0, b's can be 1, b's can be 2, b's can be 3. So in these two states, b's can be anything. But what can you say about a's? A's can be 0 or 2 or 4. 0, 2, 0, 0, 1, 2, 3, which means this line will always contain even number of A's. This line will always contain even number of A's. I will draw a line here. What will this line contain? Now, B's can be any number. Check this. 0, 1, 2, 3. B's are any number, but A's are always odd. 1, 2, 3, 4. 1, 2, 3, 4. So, this line is odd number of A's. Odd number of A's. Everyone got it? Everyone got it? Everyone got it? RBR method. With practice, you will be able to know such things. Okay. How do I know this? With practice. Now, I will draw a line here. Right. In this line, A's can be anything. A's can be 0, 1, 2, 3. A's can be anything. But if you look at B's, B's are 0, 1, 2, 3, 4, 5, which means B's are always even. You may think that this method is lengthy, but trust me, if you use this method, you can solve any big question very easily. Otherwise, if you go by the textbook method, no, this method, the stupid method of applying the cross product and getting this, trust me, you will waste 10-15 minutes on one question. You just use my method. This is a very simple method, right? Now, I will draw a line like this. Now, in this line, A's can be anything, but B's are 1, 2, 3, 4. 1, 2, 3, 4. So, it is odd number of B's. Now, what is the question given? Even number of A's and even number of B's. This is even number of A's. This is even number of B's. Now, this is the intersection. Very simple. Now, you may say, sir, even in this method also I was able to do fast. Right? And your method is also taking the same time. Then why should we use your method? Cool. I will tell you a problem where if you don't use my method, you will end up wasting a lot of time. Okay. I will show you one question like that, for example. Okay. Everyone understood this, guys? Please write in the comments. Everyone understood this? Everyone understood this? Everyone understood this? Please write in the comments. Now, I will give you a question which you will be able to solve, very easily. Okay. Now, let us say sigma equal to a comma b and language equal to set of all strings w such that number of a's in w is congruent to 0 mod 3, right? And number of b's in w is congruent to 0 mod 3. They can give any number, 1 mod 3, 2 mod 3, any number you can solve, right? Now, here my method will be helpful. Now we know that there is mod 3, which means in order to count A, we need 3 states. And here also for B, there is mod 3, which means 3 states are required for B, counting B, 3 states are required for counting A. Total number of states are how many? 9 states, very big, right? If you do cross product, trust me, it will take 15 minutes for one question. But if you use my method, you will be able to answer any question very fast, okay? So, let us count the A's horizontally, okay? So, let us count the A's horizontally. A, and then A. And let us count the A's horizontally. A, and then A. There have to be 9 states total, right? Let us count the A's horizontally. A, and then A, right? So, we are counting A's horizontally. Now, let us count B's vertically. B, and then B, and then B, and then B, and then B, right? Now, you know how to draw this diagram, but the problem is, if it is 0 mod 3, 0 mod 3, you will say this is the final state. But if the question is 1 mod 3, 2 mod 3, some other numbers can be given, then you will be confused. Then you apply RBR's method, okay? That is where RBR's method is going to be helpful. Now, what is RBR's method here? See this, draw the lines, okay? Now, let me draw this line, okay? Now, in this line, B's can be anything. See, 0B, 1B, 2B, 3B, B's can be anything. But if you look at A's, A's are always 0, 1, 2, 3. A's are always congruent to 0 mod 3, right? So, this line is A's are congruent to 0 mod 3. Got it? Now, if you draw this line, what is this line? Now, B's can be anything, 0, 1, 2, 3, B's can be anything, but A's are always 1, 2, 3, 4, which means A's are congruent to 1 mod 3, right? Now, if I draw this line, B's can be anything, 0, 1, 2, 3, 4, 5, 6, B's can be anything, but A's are congruent to 2 mod 3, right? Because 1, 2, 3, 4, 5. So, B's, A's are congruent to 2 mod 3, right? Now, you draw the horizontal lines, okay? Now, in this horizontal line, A's can be anything, 0, 1, 2, but B's are always 0 mod 3. See this? 0, 1, 2, 3, 4, 5, 6. So, B's are always congruent to 0 mod 3. Now, draw this line. See this. A's can be anything. A's can be anything. But if you look at B's, 1, 2, 3, 4, which means B's are always congruent to 1 mod 3 here, right? Now, draw this line, right? Now, A's can be anything, right? See, A's can be 0, 1, 2 or 3. So, A's can be anything. But if you look at B's, 1B, 2B's, 3, 4, 5B's, right? So, B's are congruent to 2 mod 3. Now, what is that you want, guys? A should be congruent to 0 mod 3, B should be congruent to 0 mod 3, right? So, take the intersection of those two lines. A is congruent to 0 mod 3, B is congruent to 0 mod 3. So, this is the intersection, this is the final state. Simple, right? Now, in the exam, they may ask any question, you will be able to answer it, right? If they say A's are congruent to 1 mod 3 and then B's are congruent to 1 mod 3, then what do you do? take A's 1 mod 3, B's 1 mod 3, and the intersection is this one. This one will be the final state. They can ask any kind of questions on this, right? And you will be able to find out any final state, right? 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 Yeah, in these and or questions will be there. They can ask you and or questions also, right? So whenever it is and, you take the intersection, right? Whenever it is or, you take the union. For example, if the question is A's are congruent to 1 mod 3, A's are congruent to 1 mod 3, or B's are congruent to 1 mod 3. This is an interesting question, right? Then what you should do is, you take 1 mod 3. 1 mod 3 is congruent to 1 mod 3 is this entire line, and B is congruent to 1 mod 3 is this entire line. So these 3 states and these 2 states, totally you get 5 states. You have to take union, right? All the states which are on that line. Okay, that is how you differentiate it, right? Right? Got it? Got it? Got it? Now we will see more questions on RBR model later. So this is the fastest way to solve. So these kind of machines are called grid machines. Okay, grid machines, because they look like a grid. Okay, they look like a grid. They are called grid machines. And for grid machines, no need of regular expression. It will be very complex to write a regular expression for this. It will come one page regular expression. No one is going to ask you regular expression for grid questions. Okay, you have to understand how to create a grid or how to analyze a grid, right? So in exam, either they will give you grid and they will ask you what is the language accepted by this, or they will ask you this question and they will give you grids in the options. So in any way, you don't have to write the grid. Grid will be given to you. You should understand how to write the lines and how to answer the question, right? So do you want to see more questions on grids, guys? Tell me how many of you understood this. Such as some people want break. Okay, so all of you stand up, do some stretchings. We will solve interesting grid questions. If anyone can answer those questions, they will get very good rank. Okay, I will give some difficult grid questions. Okay, let's see. All of you stand, just do some workouts. Okay, for 2 minutes we'll be back. Okay, all of you please stand and do some workout for 2 minutes and we will be back. Okay, yeah. Okay, guys. So are you ready for grid? These questions will be very interesting. If you apply RBR's rule or RBR's method, you will answer them in 2 minutes. Okay? They look very difficult. So one good part about grid machines is they have to give the grid in the question and they have to give the options, or they have to give you this question and in the options they have to give you grid machines. So grid machine will be given. You don't have to construct it. There is no other way, because they can't ask number of states. If they ask number of states, you will multiply and say. See, if they ask you, this is the minimal, okay, this is the minimal DFA or minimal NFA, they can't ask you number of states because you'll just multiply 3 into 3 and answer 9. They will not ask that. They will either give the grid in the question or grid in the options. You have to draw the lines and answer it, right? Shall we practice grid question? All of you ready? Shall we practice RBR method? All of you ready? Okay. So Sanket wants me to explain it once again. This is a big question, man. How can you ask me to repeat it? Do one thing. After the video is over, Sanket, watch it one more time. Okay. Otherwise, I will take other questions and explain the grid model. Okay. I'll take small, simple questions and explain. Okay. You'll understand it. Okay. So you tell me, what does this grid machine do? Okay. I'm giving a grid machine. Tell me the output. Okay. Tell me the output. Can there be more symbols? Ha, Shubham, there can be more symbols. Then what happens is there will be the size of the grid mesh will increase. Beyond 2 they cannot give. Otherwise, you have to count A's, B's, and that will become a 3-dimensional grid. Trust me, they will not ask you. Right. So see, Shubham, very good. Shubham Kurana, very nice doubt. No one has asked me that till now in my entire teaching career of 18 years. Okay. This is an interesting question Shubham Kurana has asked. Let me answer that question. Okay. Shubham Kurana is asking if sigma equal to A comma B comma C, and his doubt is if A's are congruent to 0 mod 3 and B's are congruent to 0 mod 3 and C's are congruent to 0 mod 3, what happens? A's are congruent to 0 mod 3, B's are congruent to 0 mod 3 and C's are congruent to 0 mod 3. Then what happens? You tell me what happens. Think about it and tell me in the options in the this one chat. Think about it and tell me. Very good, Shubham Kurana. Your doubt is very valid. Okay. Very good. SK. Who is this SK, guys? Shubham Kurana is even saying Z-axis 3D grid. Yeah, Trupti 3D grid. Chandu is saying Rubik's cube. Yeah. So what happens is, yes, you are going to count here, right? Yes, you are going to count here, and B's you are going to count here, right? Now, where are you going to count C's? You have to have a 3-dimensional. Now, I don't know how to explain this. Now you have to count C's in a 3-dimensional structure from here, right? So C's will go like this, which means I'm not able to show it on the board, but you will get a 3-dimensional, right? So one layer, on top of it one layer, and on top of it one layer, and you have to put C's in the y dimension. If you examine, if you think that this is x and if you think that this is y, you have to have a z also. That will be a 3-dimensional question. That will not be I mean, you cannot print it on the paper. In the exam paper, they cannot print it. So they will not give you 3, right? If they give you 4, that will be 4-dimensional, right? So they will not ask you that, okay? Cool. That's an interesting thing. Good, good, good. Stranger Things, RBR Things season 1. Yeah. Cool. Cool, guys. So answer me this question, okay? What does this grid machine represent? A, let me say A, and let me say A, and let me say B, and let me say B, and let me say A, and let me say A comma B, and let me say B. Okay. So what does this grid machine represent? This is how they can ask you the question, right? If you sit and analyze, it is going to take a lot of time, right? It is clear that some kind of counting is happening. A's are counted, B's are counted, but we don't know what kind of counting that is. We don't know what someone has sent a gift. Chandua, who is this guy? Rudra, yeah. Keep it interesting, Rudra. Very good. Divi has answered it. Minimum 1A, minimum 1. At least 1A, at least 1B. Who is 0? 0, what is your name? Simple. Apply RBR method. Okay. Whenever you see a grid, remember RBR. I will be sitting next to you in the exam. Don't worry. Just imagine me sitting next to you in your exam, telling you how to solve that question. Imagine me in the exam. Okay. I will also come in your dreams. Many people say that they see me in dreams because you are going to see around 1000 hours. If you are taken GATE, CS and DA, you will see me for 1000 hours, right? It is not a small movie. Okay, cool. Now see this. Now see this. Wow, Nawaz has given grid machine. Okay, now see this, guys. Draw a line here, right? In this line, B's can be 0, B's can be 1, or B's can be any number. But if you observe this line, 0 A's are there, right? So this is 0 A's. Now draw a line here. In this line, B's can be 0, B's can be 1, or B's can be any number. But A's are 1 or more. 1 or more, which means at least 1A. At least 1A. Now draw a horizontal line. Right? 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 Now, in this horizontal line, A's can be 0, A's can be 1, or A's can be more. But B's are always 0, right? In this line, there are no B's. So, 0 B's. 0 B's. Right? Now, if I draw horizontal line, right? In this horizontal line, A's can be 0, A's can be 1, A's can be 2. A's we cannot say anything, but B's in this vertical line, B's are 1 or more. 1 or more, which means at least 1B. At least 1B. Now, final state is intersection of this line and this line. So, what can you say? At least 1A and at least 1B, right? This question is given in GATE, okay? But they have given it in a different way. The way they have given it is like this. So they are asking you A, B, like this they have given A comma B, and then B, A comma B, right? This is A, okay? So you should understand that both are same. You should be able to rearrange them and answer it. Otherwise, it will be difficult for you to analyze from here. If you convert into grid, it will be easy to analyze. It will be easy to analyze. Now for grid machines, there is no need of giving any regular expression. For grid machines, there is no need of giving any regular expressions. Now answer me the next question, guys. Just use RBR method, okay? Just use RBR method. So let us say A, okay, and then B, okay, and then A. State names are not required. You can easily do this, okay? And then A, B, and then A, and then B, and then A comma B, right? Have I missed out anything? That's it, okay? Now tell me, what does this grid machine accept? What does this grid machine accept? What does this grid machine accept? Oh, Swati, it is you. Okay. Very good, Trupti. Trupti is saying exactly 1A, exactly 1B. Swati is also saying exactly 1A, exactly 1B. Chandu is saying exactly 1A, exactly 1B. Very good. Use RBR method. Draw lines. Okay. Let us draw this line. What can you say? 0B, 1B. You cannot say anything about B. But in this line, A's are always 0. 0 A's. Draw this line. 0A, 0 B's, 1B. You cannot say anything about B's. But A's are always 1. 1A. Draw this line. A's can be 0, A's can be 1. But B's are always 0. 0 B's. Now draw this line. A's can be 0, A's can be 1. But B's are always 1. 1B. Right? I have missed out something here. This is a DFA, right? A comma B. Anyway, this is a dead state. So for dead state, you don't have to analyze it. From this state, you cannot go to final state. This is a dead state, trap state, right? So now this is the intersection of this line and this line. So what does that mean? 1A and 1B, right? This is 1A and 1B. Wow. Who is this guy? Nawaz has given 3D representation. Very good, Nawaz. Yeah, how many states are there? There will be 3 into 3 into 3. Here, 9, 9, 9, 27 states. Very good, Nawaz. 27 states will be there. Very good, Nawaz. 27 states. Very good. Cool. 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 Right? Okay. So, this is about the grid machine. Now, let's see next grid machine. Okay. So sigma equal to A comma B, and you have to get at most 1A and at most 1B. Oh, no, I will not give. I have given you the answer. Now everyone will answer, okay? So see this. So this is the grid machine I want. A, B, B, A, A, B, A comma B, A comma B. Answer this question. Answer this question. Ta-tan, ta-ta, ta-tan, ta-ta, ta-tan, ta-ta, ta-ta-ta. तुझे मिलके लगा है ये, तुझे ढूंढ रहा था मैं. Yeah, Divi. At most 1A and at most 1B, right? Just draw the lines, man. Okay, I will draw this line. B's can be 0, B's can be 1. But A's are always 0. So this is 0 A's. Cool. Draw this line. B's can be 0, B's can be 1. But A's are always 1. So 1 A's. Now draw this line. Okay. A's can be 0, A's can be 1. But B's are always 0. So 0 B's. Draw this line. Okay. A's can be 0, A's can be 1. But B's are always 1, 1B. Right. Now, what are the final states? Final states are intersections of all these 4. Final states are intersection of all these 4, right? So this one or this one or this one or this one. Write about each state separately, okay? So what does this state represent? 0 A's, 0 B's, right? 0 A's, 0 B's, right? Now what does this state represent? 1A, 0B. 1 A's, 0 B's, right? What does this state represent? 0 A's, 1 B's. 0 A's, 1 B's. 0 A's, 1 B's, right? Now what does this state represent? 1 A's, 1 B's. 1 A's, 1 B's, right? Now when you have 4 final states, you have to apply OR, right? OR, OR, OR. So what does this mean? Either A's are 0, 0 or 1, 0 or 0, 1 or 1, 1. So what can you say? A's are at most 1, B's are at most 1, right? If you see A, B, either they are 0, 0 or 0, 1 or 1, 0 or 1, 1, which means A's are at most 1, B's are at most 1, right? So you can say at most 1A, at most 1B, at most 1A, at most 1B, at most 1A and at most 1B, not OR. Because if you see all the cases, A's are at most 1, B's are at most 1. So at most 1A and at most 1B. It is not OR. If you put OR, then what happens? At most 1A, at most 1A or when you put R, this condition will be satisfied for any B. So it has to be AND, okay? At most 1A and at most 1B. Right? Right? Cool. So in fact, you can easily say what this is accepting, right? You can easily say what this is accepting. It is accepting epsilon, it is accepting A, it is accepting AB, or it is accepting BA, right? So see what are all the things that are accepted. Epsilon is accepted, A is accepted, B is accepted, A, B is accepted, B, A is accepted. Only 4. So you have at most 1A and at most 1B. At most 1A and at most 1B. Right? Even though the language is simple, this is the minimal DFA for this language. Right? What about the minimal NFA? You can remove this dead state. If you want minimal NFA, you can remove this dead state and you will get minimal NFA. Right? For this language, this is the minimal DFA, and if you want minimal NFA, you have to remove the dead state. That's it. Okay. Now answer the next question. Okay. Very good, Nawaz, SDS. Very good. Okay. So the next question is, so tomorrow we are going to start discrete mathematics for gate CS and probability for gate DA. They will be for only paid users. Okay. And they will be on the paid platform. Okay. Fine. And you will get an email about class timings and all. Okay. You will get an email. You can attend the classes. Okay. Yeah. So see this. Answer this question. Answer this question, guys. Sir, could you please share the full schedule so that we also have personal plan in parallel? Yeah, Chandu, we are designing a software. So in the software, if you give your deadlines, like if you want to finish the syllabus by November, it will give you the entire plan, like every day how many hours you should study and which videos to watch. The entire detailed plan you will get. Okay, we are working on the software for the schedule. Don't worry. Okay, so just give me 1 week time, everything will be settled. Okay, very good. Trupti is saying at least 2 zeros and exactly 1 1. Yeah, Divi is also saying exactly 1A, minimum 2 zeros. Acha, exactly 1 1. Exactly 1 1 and at least 2 zeros. Yeah, Swati is also saying the same thing. Very good. Very good. Right? So now if you observe this, guys, if you observe this, listen to this. Okay? Draw the lines. Should you draw all the lines? No need. There is only one final state, right? So we need the intersection of two lines. That's it. So don't write all the lines. You need this line and you need this line, because there is only one final state. You just need the intersection of two lines to fall in that final state. You just need the intersection of two lines to fall in that state. Right? Right? Okay, cool. So tell me about this line. In this line, zeros can be 0 or 1 or 2 or 3 or anything. But in this line, ones can be only 1. Right? So this line says exactly 1, 1. Now, what is the other line, guys? This line, this horizontal line. Now, if you see, ones can be 0 or 1. You cannot say anything. 0 ones are there, 1 ones are there. But if you look at 0, they can be 1, 2 or more. 1, 2 or more, right? Which means you can say at least 2 zeros, right? Therefore, the answer is exactly 1, 1 and at least 2 zeros. Exactly 1, 1 and at least 2 zeros, right? Right? SDS. SDS is giving the language, not a finite language, man. Is it a finite language? When I say exactly at least 2 zeros, zeros can be 2, 3, 4, 5, right? So there can be many zeros. But exactly 1, 1. So regular expression for this will be, there can be at least 2 zeros, right? And 1, 1. Okay. So at least 2 zeros. Let's not write the regular expression, because you have to put all this 0, 1, 0 and then 1, 0, 0 and then 1, 0, 0, 1. That's it. First place, second place, third place. You can have any number of zeros before and after. You can have any number of zeros before and after, before and after, right? So there is only exactly 1, 1 and 2 zeros, exactly 1, 1 and 2 zeros, exactly 1, 1 and 2 zeros. Put a plus. This plus this plus this. This is an infinite language. Why? You got a loop in the final state. Whenever you get a loop, and if that loop is either in the final state or leading to final state, the language is infinite. You cannot say it is finite language, right? You cannot say it is finite language. But no one will ask you for regular expression for a grid machine, because in this case it is easy, but in other cases it will be difficult to write the regular expression. Right? Right? Okay. Answer me this question. తెల్లవారితే కనురెప్పల తొలి మెలకువ నువ్వే, నా గుప్పెడు గుండెల్లో చిరు చప్పుడు నువ్వే, పొలమారితే నీ మనసుకి అది నా పొరబాటే, నీ పేరే పలకటమే పెదవుల కలవాటే, వెన్నెలలా ఉంటుందే నీ పక్కన చోటే, వేకువలా చూస్తోందే నువ్వు నడిచిన బాటే, ప్రాణాలే తీస్తోందే నీ ఊహలతోటే, నా మనసే నీదాయే వినదే నా మాటే, ఎవరే ఎవరే ప్రేమను మాయంది, ఎవరే ఎవరే ఈ హాయికి హృదయము చాలంది. గందు లాంటి కందులున్న జున్ను లాంటి పిల్ల, నవ్వుతోటి నన్ను పిలిచి పారిపోతే ఎల్లా. Okay, answer this. Okay. I think I have given everything. Okay, answer this. Very good. Divi is right. Yashwant is right. Is there any WhatsApp group for this course, Ankita? WhatsApp group is not there, but we have a Telegram channel. The reason is WhatsApp, we are not able to see the old chats. Telegram is better. Okay. So answer this question, guys. So see this. Now this is the final state. Don't draw all the lines and waste your time. Just write 2 lines such that intersection is this. Okay. So draw a horizontal line and draw a vertical line. That's it, over. Right. Now see what this vertical line is. 1A, 2A, more A's. 1A, 2A, more A's. 1A, 2A, more A's, which means at least 2 A's, right? At least 2 A's. Simple. Now see this horizontal line, right? A's can be anything, 0, 1, 2 or anything, but B's are 1, 2 or more. This is B, right? Here also I forgot B. Yeah. So B's are 0, 1, 1, 2 or more. 1, 2 or more. 1, 2 or more, right? So it is at least 2 B's. At least 2 B's. So it is at least 2 A's and at least 2 B's. At least 2 A's and at least 2 B's. Very good. Everyone has answered it. At least 2 A's and at least 2 B's. At least 2 A's and at least 2 B's. Right? Answer this question, okay? What does this grid represent? Write it clearly in your notebook, okay? Because there are a lot of arrows and all this, right? So write it clearly in your notebook, okay? Here it is A comma B. A comma B. Let us say this is the final state, okay? Very good. Trupti, you are very fast. Exactly 2 A's and exactly 2 B's. Chandu, you are very fast. Divi, you are very fast. SDS, you are very fast. Very good, guys. Very good. Cool, right? So, so draw only 2 lines. This is 1 line and this is 1 line, right? So in this line, if you look at this horizontal vertical line, there can be 0 B's, 1 B or 2 B. But if you look at A's, there can be only 2 A's, 2 A's, 2 A's. Therefore, this is 2 A's. And if you look at this horizontal line, okay, if you look at this horizontal line, A's can be 0, 1 or 2, but B's are always 2. B's are always 2, right? 2 B's. It is exactly, right? It is exactly 2 A's and exactly 2 B's. Okay, exactly 2 A's and exactly 2 B's. Right? That is the answer. Now, this is a finite language, isn't it? This language is a finite language, right? Right? Because either on the final state or on the way to reach it, you don't have any loop. If you have to reach this final state, look at all possible paths. 2 A's, 2 B's, A, B, A, B, 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 A, 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 B, B, A, right? So basically you have 2 A's and 2 B's. How many strings, how many permutations of this are possible? How many jumbles, how many arrangements are possible? That is what we are going to see tomorrow in discrete mathematics, combinatorics. That is why I want to discuss combinatorics, because there are counting problems in TOC which you will learn in combinatorics or permutations and combinations. That is why I want to do counting. There I will tell you with AABB, the number of permutations are 4 factorial. 1, 2, 3, 4, 4 factorial. 2 A's are repeating, 2 B's are repeating. 2 factorial into 2 factorial. Right? So I can't count all of them. So it is 2 into 3 into 4 divided by 4, which means you are going to get 6 strings. Now they may ask you how many strings are accepted. How many strings are accepted? 6 strings. Now if you want, you can write all the 6 strings, right? So what are all the 6 strings? One is AABB, other is BBAA, okay? Other is ABAB, other is BA, right? And where are 2 more? BBA or BAAB. So these are all the 6 strings, which means you have 6 routes possible from the starting state to the final state. 6 routes are possible. Now, how did I derive this formula? I will teach you in discrete mathematics. This is arrangements with repetition. Now, whenever you have arrangements with repetition, you have to, I will show you many problems in the discrete mathematics, in combinatorics. Whenever you have arrangement with repetitions, the formula is n factorial divided by n1 factorial, n2 factorial, so on, nr factorial. This is the arrangement with limited repetition. Here the repetition is limited. You have only 2 A's and 2 B's. It is not unlimited. You cannot use unlimited number of A's and unlimited number of B's. Right? 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 Okay. Yeah. So Chandu is saying 4C2. So how did Chandu get 4C2 is, how did Chandu get 4C2 is, you have 4 places. Out of these 4 places, choose 2 places for A's. You choose any 2 places for A's. Automatically remaining 2 places are going to be B's. Choose, this is what? That is why I need counting. Counting is a very important thing for gate. It will be asked in probability, it will be asked in combinatorics, it will be asked in permutation combinations, it will be asked in this one, aptitude, and it will be asked in many other subjects like TOC, digital, CO, OS, CN. You have counting everywhere, probability everywhere, right? So that is why it is important. Now, how did Chandu get 4C2 is because you have 4 places. Out of these 4 places, choose 2 places for A's. Okay? Choose 2 places for A's. That's it. You don't have to choose places for B. Why? Because remaining places anyway B is going. That's it. That is why he got 4C2. Now, this formula is NCR. This formula is NCR. Right? So, this comes under the group called combinatorics with no repetition. How are these two becoming equivalent? Here I have shown you the proof. And trust me, combinatorics, permutations and combinations is my favorite subject. I will play with them. You will be wondering, how am I playing with these questions? Mathematics is my favorite. If you have to get a good rank in GATE, you can't do it without mathematics. If you are very good at mathematics, you will get under 100. You don't even want my coaching. You will get under 100 if you are very good at mathematics. And we are going to rock mathematics. Okay. So this is just an example. Okay. Fine. We are going to see everything. Okay. Okay. Fine. So what was the question we solved? 2 A's and 2 B's. Right. Okay. Solve one more question, guys. పదవే నీ రెక్కలు నా రెక్కలు చాచి పోదాం ఈ దిక్కులు ఆ పక్కలు దాటి పరువన్ను రాదారి ఆకాశమైందే పై పైకెళ్ళాలన్నదే చెకోరి ఎప్పుడు మారకు చాచి పోదాం దిక్కులు ఆ పక్కలు దాటి పరువంలో రావాలి ఆకాశమైందే పై పైకెళ్ళాలన్నదే ఓరి. See, why am I writing without printing is because while I am writing, you will be able to analyze it. That is why. Okay. While I am writing, you will be able to analyze it. Okay. Answer this question, guys. Hmm. One minute. What was? Yeah, this was the question. Yeah. Okay, cool. Very good. Everyone has given. Sunil right, Chandu right, Manu right, SDS right, Trupti right, Manyam Suguna right. Very good. Everyone has answered. Almost everyone has answered. Almost everyone has answered, right? Cool. So draw the lines, okay? Draw the lines. Now we have a lot of practice. So this is 0A's, right? And this is 1A, right? And this is 2A's, right? And this is 0B's, right? And this is 1B, right? And this is 2B, right? Now it is intersection of all these three, right? So now if you check A's and B's can be 0, 0, right? Or 0, 1 or 0, 2, right? So see this 0, 0, 0, 1 or 0, 2, or you can see this line and these three lines, right? 1A, 0 B's, 1A, 0 B's, 1A, 1B, 1A, 2B. Similarly, if you look at this line, 2A's, 0 B's, 2A's, 1B, 2A's, 2B's, right? So what can you say about this? You can say that it is at most, right? At most 2A's and at most 2B's. And this is a finite language, guys. This is a finite language. Okay? Because both are at most. And you can see that there are no loops anywhere here. Loop is in the dead state. This is a finite language. At most 2A's and at most 2B's. At most 2A's and at most 2B's. Right? So how many total strings are there? This is epsilon, this is B, this is BB, this is A, this is AB, this is ABB, right? And then this is AA, AA, and this is, what is this? This is AAB, AAB, and this is AABB, sorry, and this is AABB. But if you observe it, is it visible? Is it visible? Let me just see, is it visible? Yeah, I think it is visible, right? See, the last one is 2 A's, 2 B's, right? Which means AABB. So, are there only 1, 2, 3, 4, 5, 6, 7, 8, 9 strings? Are there only 9 strings, guys? Can you tell me? Can you tell me? Are there only 9 strings? Are there only 9 strings? Can you tell me? Are there only 9 strings? Listen. So, this is one string, this is one string, this is one string, right? I'm not going into permutations and combinations, I'm just showing you. This is one string. Now, AB can also be written as BA. Now, ABB can also be written as BAB, BAB, or BAB, or BBA, right? So, A can be in the beginning or in the middle or at the end. AA, you cannot do anything. Now again, AAB can be written as BAA or ABA. And again, this AABB can be written in 6 ways. So, you have to count all this. You do that counting. I am leaving it as exercise. Okay. You do that counting. I am leaving it as exercise. Okay. Okay. Fine. You understood, right? Even though you get, see, when I say 1A and 1B, it can be BA or AB. When I say 1A or 1B, it can be BA or AB. When I say 1A, 2Bs, it can be BBA, BAB or ABB. So that is why we get more strings. But whatever it is a finite language. This machine is representing a finite language which is at most 2 A's and at most 2 B's. At most 2 A's and at most 2 B's. Guys, are you enjoying the class? Please write in the chat, in the YouTube and Telegram, are you enjoying the class? If you really loved the class, say great session. Everywhere. We'll take break for 2 minutes and then we'll continue. Everyone type if it is a great session. Everyone say if I am the best. Right? Everyone say if it is a great session, if you are enjoying it. On the YouTube and Telegram. Okay? Cool. Cool. Great. Okay? So all of you stand up, do some stretchings. We will continue. Okay? All of you stand up, do some stretchings, and then we will continue with some exciting questions. Okay, we'll continue with some exciting questions. Just do some stretchings, guys, all of you. Okay, guys, let's do one more. Okay, let's do one more. Cool. I'll give you a big question. Okay, I'll give you a big question. So answer this question. Okay, See, when I do combinatorics, you will find all these questions very easily be solvable. And one more thing I am going to do, I will solve all the PYQs of all the subjects, and we will solve them within 1 minute or 2 minutes. It will not take much time. When I'm explaining the concept, I am spending around 3 to 5 minutes on one question. But when we do PYQs, I will give you all the shortcuts. You will be able to solve in 1 minute, 1 minute or 2 minutes. That's it. Any subject, any question, 1 minute or 2 minutes, except CO. Except CO and OS, there are some questions which will take 3 minutes. That's it. Okay. Okay. See this, answer this. I will give you shortcuts in all the subjects. Okay. So tomorrow you are going to get the time for the discrete mathematics and probability class. Okay. So you'll get an email. Those who has registered, only for them. I will not conduct on YouTube. I will conduct on the paid platform. Okay. Because I can't do all the subjects on YouTube. Okay. Because there is a value to my time, and it is a privilege to learn from me. Okay. And you are paying for the privilege. Okay, cool. Answer this question, guys. Let me see if I have missed out any transitions. Very good. Divi, you are very fast. Yeah, Tripti, you are always there, Tripti. Tripti, have you registered for the class? Tripti, have you registered? Are you a registered student, Tripti? You are doing really well. Chandu, you are doing really well. Are you registered? Divi, very well. Anjali, very good. SDS, Sunil, very good. You are all doing very well. You will all have a chance to get into top 100, Manu. Very good. You are following it, okay? So, see, we don't have to draw all the lines. Just draw the lines in such a way that final state falls in the intersection, okay? Just draw the lines in such a way that final states fall in the intersection, right? So, I am going to draw a line like this. And this line is important because intersection is there. 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 Now let's talk about this vertical line. Okay. So 1A, 2A or more A's, right? Which means you can say at least 2 A's, right? At least 2 A's, at least 2 A's. Now, what about the B's here? It is 0 B's. What about the B's here? It is 1B. What about the B's here? It is 2B. What about the B's here? It is 3B's. 3B's. Right? Now, if you combine all of these, if you combine A's and B's, so what can you say? A's are at least 2. A's are at least 2 and B's are 0, or A's are at least 2 and B's are 1, and A's are at least 2 and B's are 2, and A's are at least 2 and B's are 3, right? So you have multiple final states, so you have to put a R, right? Now, if you want to combine all this and say in one line, at least 2 A's and at most 3 B's. At least 2 A's and at most 3 B's. At least 2 A's and at most 3 B's. So you can say at least 2 A's and at most 3 B's. At least 2 A's and at most 3 B's. At most 3 B's. Right? That is a easy way to answer it. Okay. Now I will give you a different question. Okay. Now we will see divisible by. Okay. So my question is, I want all the binary numbers, right, divisible by 3. All the binary numbers divisible by 3. Can someone do this? So they are talking about binary numbers, so they will not give you what is sigma, right? What is the alphabet? See, they are talking about binary numbers divisible by 3, so they will not give you sigma. You have to understand what sigma is, right? So what will be sigma, guys? For binary numbers, sigma is going to be 0, 1. For binary numbers, sigma is going to be 0, 1. For binary numbers, sigma is going to be 0, 1. Can you do the minimal NFA or minimal DFA for this? Minimal NFA or minimal DFA for this? How is a binary number divisible by 3, Divi? Which means binary number when interpreted. Okay, let me write it. Okay, so binary number when interpreted as decimal number is binary number interpreted by decimal number is divisible by 3. Is divisible by 3. Binary number when interpreted as a decimal number is divisible by 3. Right? Try it, guys. Write it on the Telegram channel. Try it. This is a different model. Just try this, okay? This is a different model. Just try it, okay? No, sir. Like in decimal, its sum of digits is... No. It is not sum of digits. Binary number, when interpreted as a decimal number, is divisible by 3. For example, let me give you this 1 1. What is 1 1 in decimal? 3. So you have to accept 1 1. It is divisible by 3, right? Now 1 0 0 1. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this is 9. So this you have to accept this. You have to accept this. Or 110, right? So 110 is 6, right? So you have to accept this. You have to accept such strings. You have to accept such strings, okay? Try it. It is an interesting question. Try it. Try it, guys. It is an interesting question. Try it. Not able to get pattern. Very good. Okay. So do you want the shortcut or do you want the process? Do you want the shortcut or do you want the process? Do you want the shortcut or do you want the process? Okay. First, what do you want? Shortcut or the actual process? Proper process. Okay. Let us do proper process. Okay. Let us do proper process. Cool. So now whenever you divide any number by 3, see, whenever you divide any number by 3, remainder can be 0 or remainder can be 1 or remainder can be 2. Simple, right? That's the basics. Whenever you divide any number by 3, remainder can be 0, remainder can be 1 or remainder can be 2, right? And one more assumption is, let us say it is given in the question, assume epsilon is 0. Assume epsilon is 0. Okay? Assume epsilon is 0. Otherwise, there will be a different process. Okay? So remainder can be 0 or remainder can be 1 or remainder can be 2. So we are going to have 3 states. One is remainder is 0, remainder is 1 and the other one is remainder is 2. Remainder can be 0, remainder can be 1 or remainder can be 2. Okay? Okay? Now let us say we want to accept all the numbers which are giving remainder 1. Okay, remainder 0. So any number of zeros I get, I will always get a remainder 0 because the number is 0. Now if in Q0, if I get a 1, its value is 1. When I divide 1 by 3, the remainder is 1. Cool. The remainder is 1 now. Now let's see about Q1. How did I reach Q1? By seeing a 1. Now if I see a 0, I reached Q1 by seeing a 1, isn't it? By seeing a 1, I reached Q1. If in Q1, if I see a 0, the number is 2. Therefore, the remainder when I divide with 3 is 2. So, on 0, I will go here. Okay. Now, Q1, how did I come here? By seeing a 1. By seeing a 1, I came here. By seeing a 1, I came here. Right? Right? Now, if I see a 1, then what does that mean? The number is 3 and the remainder is 0. So if I see a 1, the remainder is 0. Now how do I reach Q2? By seeing 1, 0, right? By seeing 1, 0, I reached Q2. Now if I see a 0, the number is 4 and the remainder is 1. Therefore, go back. Now how do I reach Q2? By seeing, see what am I doing? For every state I am trying to see what happens on 0 and 1 so that I can make a DFA, right? In fact, for this question, NFA and DFA both will be same. And this is minimal. Why? Because when you divide a number with 3, you have to have 3 states representing 3 reminders. So you cannot minimize more than that. So this is a minimal DFA, right? But we are not done yet, okay? So how do I reach Q2? By seeing 1, 0, right? By seeing 1, 0. Now if I see a 1, the number is 5 and the remainder is 2. So if I see a 1, the number is 5 and the remainder is 2. So this is the process. This is the process. 3 states, 3 remainders. And what is epsilon, guys? Epsilon is 0. That is why Q0 is final state. That is why Q0 is final state. Right? 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 Everyone understood the process? Everyone understood the process? I'm not going to give you a shortcut now. I want you to practice this. I want you to practice this. Okay? And let's make a small change. Okay? And let's make a small change. And let's make a small change. Okay? Now let us say this assumption is not given. Assume epsilon is 0 is not given. Okay, let's see that later. Now if the question is binary number interpreted as decimal number is, let us say, congruent to 1 mod 3. What does this mean? Remainder is 1. In that case, Q1 will become the final state. Now if they say congruent to 2 mod 3, in that case, Q2 will become the final state, right? Now let us say they are saying that the number is divisible by 3, but they have not given the assumption that epsilon is 0. They have not given the assumption that epsilon is 0. They have not given the assumption that epsilon is 0. What does that mean? Epsilon is not a number. So you cannot accept epsilon. Now you made initial state as final state. You made initial state as final state and you are accepting epsilon also, but epsilon is not a number. How can you avoid that? put a new initial state QS. Okay. On 0, you go here. Now epsilon is not accepted. If I see a 0, remainder is 0. If I see a 1, remainder is 1. So I am going to add a new state. So just be careful. If nothing is given, epsilon is not a number. If they are talking about binary numbers, epsilon is not a binary number. You should not accept epsilon. In that case, add a new state. When it is clearly given that divisible by 3. If they say congruent to 1 mod 3, then Q1 is the final state and epsilon is anyway not accepted. In that case, QS is not required. In this case, QS is not required. If they say 2 mod 3, then Q2 will be final state. Initial state will not be final state. Therefore, there is no need of adding extra start state. There is no need of adding extra start state. There is no need of adding extra start state. Right? Okay. Now you understood all the variations of this model, and now this is going to take a lot of time to do in the exam if this number is bigger. Okay. For example, I'll give you one question, then I will tell you RBR method. Okay. In RBR method, you will be able to answer this in probably 5 seconds. In 5 seconds, you will be able to answer this in RBR method. How many of you want RBR method? In 5 seconds, you will answer this question in RBR method. How many of you want RBR method? How many of you want RBR method? Very good. Okay. So before going to RBR method, just try this question. Okay. So my question is binary number when interpreted as decimal number is divisible by 5. Can you do this, guys? Try this, then you will understand the difficulty of the question. Earlier question was simple, only 3 states when you divide with 3, but here there will be 5 states when you divide with 5. Can anyone do this? How much time will it take? Here we have 5 states divisible by 5. You will get RBR method. Try this one. Okay. Just for fun, try it. I'll give you 3 minutes. Try this, then we will go with RBR method. Okay. Then we'll go with RBR method. Very good. Someone has done that. Okay. Now let's see RBR method. Okay. Now let us say divisible by 3, right? So I will show you what RBR method is. I will solve it in 5 seconds. Set your timer. Okay. So 0, 1. We know that there are two states, Q0, Q1, Q2. Q0 is the initial state and the final state. So just write like this: Q0, Q1, Q2, Q0, Q1, Q2. You compare it, both are same. This one without QS is same as this. I am writing Q0, Q1, Q2, Q0, Q1, Q2 over. That's it. Q0, Q1, Q2, Q0, Q1, Q2 over. That's it. Nothing else. Initial state and final state are same. But the problem here is that you are accepting epsilon also, right? So if you don't want to accept epsilon, don't make it initial state, add a new initial state, and on 0 go to Q0 and on 1 go to Q1. That's it. So this is the final answer if they say that binary numbers. If they say epsilon is 0, then you can make Q0. Or if they say congruent to 1 mod 3, you don't have to have QS. You can have this one as Q1. Understood this? Now let us see divisible by 5. Okay. Now let us see. Divisible by 5. Now let us see divisible by 5. Okay. So how many remainders are there? Q0, Q1, Q2, Q3, Q4. Use RBR's method. 0, 1. So write Q0, Q1, Q2, Q3, Q4. Again write Q0, Q1, Q2, Q3, Q4 over divisible by 5. So actually Q0 is supposed to be the final state, but if you make it initial state, the problem is epsilon will be accepted, which is not a binary number, right? So that is why you are going to add a new final initial state QS, and on 0 you are seeing a number 0, so remainder is 0, and if you see a 1, the remainder is going to be 1, so Q1. That's it. Simple. So this is the DFA as well as NFA. Now if they say congruent to 1 mod 5, then what happens, guys? Q1 becomes the final state, right? So simple. Q1 becomes the final state. How many states we have? Q0, Q1, Q2, Q3, Q4, 0, 1, Q0, Q1, Q2, Q3, Q4, again Q0, Q1, Q2, Q3, Q4, right? Now congruent to 1 mod 5, right? Which means this is the final state. Now that Q1 is the final state, Q0 is not the final state, you can have it as the initial state, no problem. You can have it as the initial state. There is no need to add QS. There is no need to add QS. This is the shortcut. This is the shortcut. Every time 2 iterations to be filled, that depends, Nawaz. Okay, I will give you one more question. Okay, I'll give you one more question. Okay, so base 4 number when interpreted as decimal, number, base 4 number when interpreted as decimal number, let us say is divisible is divisible by, let us say 5. Let us say 5. This will be impossible to solve within 2 minutes if you follow the process. Use the RBR method. Use the RBR method, you will be able to solve it easily. If you use the RBR method, you will be able to solve it easily. Right? So what is the RBR method, guys? So sigma equal to base 4 number means 0, 1, 2, 3. In base 4, the digits are 0, 1, 2, 3, right? So, and divisible by 5 means there will be 5 reminders. So Q0, Q1, Q2, Q3, Q4, right? And 0, 1, 2, 3, right? Now, divisible by 5, which means this has to be the final state. Okay, this has to be the final state. Now just write this: Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4. If you have to go by process, it will take hell a lot of time. Use RBR method. Okay. Now it has to be divisible by 5. So you cannot make initial state as final state because epsilon is not 0. Epsilon is not a number. Then you add a new initial state. And that new initial state, if it sees a 0, the remainder is 0, so it will go to Q0. If it sees a 1, the remainder is 1, it will go to Q1. If it sees a 2, the remainder is 2, it will go to 2. If it sees a 3, the remainder is 3, it will go to Q3. Right? This is the initial state and this is the final state. If they say the number is congruent to, let us say 1 mod 5. The number is congruent to, let us say 1 mod 5. The number is congruent to, let us say 1 mod 5. Then what happens, guys? This one will become the final state. Q0 will become the initial state. There is no need of QS, right? Other than divisible, if you see congruent to 2, congruent to 1, congruent to 3, you will not have a new state. You will not have a new state. Okay. Did you like RBR method? Did you like RBR method? But there are some exceptions. Okay. So in tomorrow's class, we will see the exceptions. There are some exceptions. In tomorrow's class, we will see the exceptions. In tomorrow's class, we will see the exceptions. Okay. In tomorrow's class, we will see the exceptions. What kind of exceptions are there? Okay. I will teach you in tomorrow's class. Before I take that class, I have to solve some other questions and again I'll come back here, right? See, the way I teach TOC is in a systematic way for you to understand. If I solve one question here, one question there, one question here, you will not understand it. I'm taking all the models which are together and solving them so that there is a systematic way to learn, and that way you will understand it better and also revision will be better, and in the exam you will be able to solve easily. Okay, I will solve all the PYQs within 2 minutes. Challenge. But maybe explaining you may take some time, but given any question to me, I will write the solution within 2 minutes. Any PYQ of any subject. Okay, fine. Cool. So we will end this session here, guys. So thank you all. How was the session? Can someone please tell me that this session is a great session? Can someone please tell me that this session is a great session? Shubham Khurana. What did you understand? I haven't understood the normal process. RBR is clear. How and why kind of doubts I am having. Okay, Shubham, we'll do one more time. Okay, for Shubham, we will do one more time. Okay. So now let us say this divisible by 3. Okay. Divisible by 3 question. We know that there are 3 reminders Q0, Q1, Q2. Okay. Now we want to build a DFA. So for every state, for every symbol, you have to say what happens, right? Now let us say this is the initial state. Okay. Now this is remainder is 0, therefore the number is divisible by 3. Okay. Now think about what happens if I get a 0 in the initial state. The remainder is 0, right? What happens if I get a 1 in the initial state? The number is 1, therefore the remainder is 1. You go here, right? Now I am in Q1. How did I reach Q1? By seeing 1. Okay. Now after seeing 1, what happens if I see a 0? The number is 2 and the remainder is 2. So go here. Now I am in Q1. How did I reach here? By seeing a 1. Now after seeing a 1, if I see a 1, the number is going to be 3, right? The number is going to be 3. The number is going to be 3 and the remainder is 0, right? Right? Now Q0 is over, Q1 is over. Now what about Q2, guys? How do I reach Q2? By seeing 1 0, 1 0. Okay. Now if I get a 0 in Q2, the number is 1 0 0, which means 4 and the remainder is 1. If I divide 4 by 3, remainder is 1, therefore it is 0. Now it is not yet over. You have to see what happens if you get a 1. Now, how did I reach Q2? By seeing 1 0, I reached Q2, right? By seeing 1 0, I reached Q2, right? By seeing 1 0, I reached Q2. Right. Now if I get a 1, then what is the number? 5. Then what is the remainder? 2. So 1. That's it. Now the only problem with this is epsilon is not a number, but epsilon is also coming in the language, right? We need only binary numbers, but epsilon is also coming in the language. Just to avoid that, you add a new state QS. Now if you see a 0, remainder is 0. If you see a 1, remainder is 1. You add this. That's it. That's it. But new state is not required if they say congruent to 1 mod 3. If they say congruent to 1 mod 3, new state is not required. Or if they say congruent to 2 mod 3, new state is not required. Right? Now you understood when the new state is required, when the new state is not required. Right? So there are some exceptions which we will see tomorrow. Okay? There are some exceptions which we will see tomorrow. Okay. There are some exceptions. There are some exceptions which we will see in tomorrow's class. Okay. Thank you, guys. Good night. Good night, everyone. Sweet dreams and see me in the dreams. Okay. Cool. Cool. Santu,